Okay, so let us go to the next problem of this section now. Now here G is a set of all matrices which are of the form x, 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 x. Means G contains all those 2 by 2 matrices where all the 4 elements are the same, all the 4 entries are the same, and that x should not be equal to 0. So if I just draw a small picture over here, I will say G. G will contain which type of matrices? It will contain 1, 1, 1, 1. It will contain 2, 2, 2, 2, and so on. Maybe it can also contain something like half, 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 half. Any real number where all the 4 entries are equal. All the 4 entries are same. So outside this, you will find many matrices. Something like this 1, 0, 0, 1. This is our identity matrix. Any matrix with some random entries, right? So what is G? I am going to collect only those matrices where all the 4 entries are the same. Now what is this exercise telling us? They are saying that G is a group. This G forms a group with respect to usual multiplication. This is given to us now. Okay, and what are we supposed to find? In that case, we are supposed to find identity of this group. Now you clearly see that identity of this particular group cannot be our identity matrix because identity matrix is not in this set. So we have to find a person in this set only who will be working as the identity of the set. A very simple observation might tell you that 1, 1, 1, 1 should be the identity of the group, but that is actually not correct. Okay, so we have to be very careful when you are saying the identity. So if I have an element over A or here, a matrix A here, okay, what property should the identity of this group satisfy? That identity matrix should be, that identity of that group should have a property that this A multiplied by this identity or this identity of the group, that should again give you the matrix A. What are the entries of A matrix? A matrix is in this set. So the matrix, the entry of A will obviously be what? X, 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 X. Where what is X? X is not equal to 0. We have to pay attention at this. Okay. So 0 matrix is also outside because 0, 0, 0, 0 nahi chalega, right? So let me go for the first part now. Let A be any matrix in the set G. Means how is A looking like? What is the format of A? A will look like X, 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 where this X cannot be 0 and it is a real number. Correct? And let E be the identity of G. Identity of G. So how will this E matrix look like? Now this E matrix will also have all the entries same, E, because E matrix is also in this set. So I will say that, say E is equal to E. What is E? E is not equal to 0, right? And A multiplied by E, what should be A multiplied by E? Because E is the identity of this set, means A multiplied by E should again be equal to how much? It should again be equal to A. What is A? Now let us do the calculations. X, 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 X multiplied by E should be again equal to how much? X, 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 X. So do you see that when I simplify this matrix multiplication, it will be XE plus XE, which will become 2XE. So this will be in that 2XE. All are 2XE. If I multiply these two matrices, this is also 2XE. 2XE is equal to how much? X, 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 X. And this means that 2XE must be equal to how much? X. Can I cancel the X on both the sides? Yes, I can cancel the X on both the sides because X is not equal to 0. So this means that 2E is 1 and therefore the value of E must be half. E is half. Therefore what is our matrix capital E. What is our matrix capital E? Matrix capital E is how much? Half, 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 half. So in this group, I understand that this matrix half, 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 half is the identity of this group. So this matrix is actually our E matrix, correct? So we have found out the identity in this group. Does it belong to this group? Yes, because all the entries are same, the entry is non-zero. So this belongs to the set G and it serves as the identity of G, correct? Okay, now we have to go to the second part of finding the inverse of this element in this group. So I will take an element here now. That element is y, 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 y. And I am going to find an element in this set which is inverse of this particular person. Now that matrix, that inverse, I am going to denote by say alpha, 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 alpha. So what is alpha, 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 alpha? It is inverse of the matrix y, 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 y. If this is the inverse of this matrix, means if I multiply both of them, I will get the identity matrix, I will get E, right? Because this is the definition of inverse. This element multiplied by its inverse will give you the identity of the group. So who is given to us now? So I'm going for the second part. I'm writing the solution now. So let alpha, this is the solution of the second part. So let alpha, 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 alpha be inverse of y, 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 y. Therefore their multiplication will be equal to how much? The identity of that group. Who is the identity of that group? It is E, right? Who is E but half, 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 right? This is given to us. And this is the matrix I am trying to find, right? Because it is given to us that you have to find the inverse of this matrix. So I have to find what is this matrix. If I multiply here, do you see that? I will again get alpha y plus alpha y, so I will get 2 alpha y, 2 alpha y, 2 alpha y and 2 alpha y is equal to half, 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 right? What do you know about alpha and y? One very important information about alpha and y we know is that alpha is also not equal to 0 because it is in this set. And y is also not equal to 0 because again in this set, because this set has a property that that element cannot be 0, right? So let us simplify this. So this means that 2 alpha y must be equal to how much? 2 alpha, because all equations are same. 2 alpha y, 2 alpha y all are same. 2 alpha y is equal to half, and this means the value of alpha is 1 upon 4y. Means the matrix alpha, 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 alpha which we wanted to find is nothing but what? 1 upon 4y, because alpha is 1 upon 4y, 1 upon 4y, 1 upon 4y, 1 upon 4y. So this matrix is the inverse of which matrix? It is the inverse of the matrix y, 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 y. This y is obviously not equal to 0 because this y was not equal to 0. So we have found out the solution of the second part also. Okay, so this finishes our exercise here.